Hi, I have a mail that seems to be what I've been able to do. Yes. Okay, sounds good, and then we can go out, right? Okay, thank you so much. Thank you. So we can go now, bring him in.
I have class.
Do you want me to bring him in or wait for you?
You can bring him in. I'll send you the video that I took.
video.
All right, welcome back, people. How's it going tonight?
All good?
All right, so good. Notice that in the Math 120 class, there's two things I want to make note of, because there's people here that are only in the Math 120. So in the Math 120, there's been that test 4. Let me share the screen. All right, this has been open. I think I opened it up Monday. Let you open it up Monday. It's a different type of test. It's when you can just take any time before Thursday class time. It closes at class time. And so it's just, we didn't have enough time for it before the midterm. So I'm giving it now. And the reason being is if I give 5 tests, then I can drop one of them. And so that'll help improve things for you. And then in the Math 020, in the Math 020, which is the one that not everybody in here is in, but there's some people that here that don't have it, that did not come today in 020. But just realize in there is a review for the 020 exam in 1 week. Okay, it's a mini final exam in the sense that it only covers the first 3 chapters, and it's not as intense as the Math 120. So that's going to be our closeout on any kind of tests or whatnot for exams in the 020. The rest of the material, the rest of the time in the 020 will be spent on preparing for the chapter 11 stuff and the final exam. Okay. So that being said, we're off to the races here. So make sure you're keeping up with those. All right. Anybody got any questions? All right. So, all right. So let's get over to chapter 11, and we'll finish that up probably in about 3 days' time. And then, so after that, we'll start working on the review for the last test in this class. All right. So next week, we'll pretty much be able to finish up everything in chapter 11. It's fairly short, even though it has seven sections. I'm going to bounce through 1 through 3 tonight. So there's not a whole lot to those first 3 sections. And like I said, that's why I'll be able to finish those out tonight. And then the majority of the time will be spent on 11.5. I'm sorry, 11.4, 11.5, 11.6, and 11.7. And even those are not that bad. It's more like, especially sections 3 and 4 and 5, it's number crunching, I guess you would call it. And so it's not as difficult as you would think. All right. That being said, has anybody got any questions like I said, is we're kind of now going to be intensely involved in material for the next 3 weeks. And we'll finish out the 020, like I said, with the math 020 exam in 1 week. And then this time, the time that we usually use in the 020 will be geared towards specifically getting us into the math 120. There's no more assignments or anything or tests in the 020 after 1 week. All right. Any questions before I start the lecture for the new material? All right. So chapter 11 is entitled Statistics, and probability is the basis for statistics, although you don't need to understand all the whys and wherefores of chapter 10, but that is the basis for statistics. Now, the first section of this is really just basic definitions, and I'll just briefly go over this since it's really not that important in the great scope of things. There's only about 3 or 4 definitions that really are important. All right, there's 2 types of statistics. There's what we call descriptive statistics, which is the scope of this class. It's basically just doing the number crunching calculations that I mentioned. Inferential statistics is the scope of the second half of Math 203, which a lot of nurses take that as their second math. And if you need a second math, that's one of the ones you could consider taking. There are other ones as well, but usually for nurses, that's what they statistics. All right. So,
Dr. Cruz, Mr. Cruz, can you repeat what you just said? I just joined.
all right.
How do you
So
feel?
we're just going over the math, the beginning of chapter 11, statistics. So this class right here, or the final chapter, focuses on descriptive statistics, basically just number crunching. Inferential statistics is what would be in Math 203 in the second half of the course. Now, the reason why this class is called statistics is because statistics is the science of finding out about the population by doing calculations on a sample that is representative of the population. All right. So we got to get a sample because it's a subset. And that's one of the reasons why we went over that in chapter 2. So a sample is a subset of the population, but we want that sample to be representative of the population. The population is not always something we can just go out and lay our hands on. It may be very big. If you think about the population of the United States is 330 million people, every 10 years we do something called a census, where we actually go out and we collect data on everybody. But you can't do that on a regular basis if you want to find out about how many people live in Louisiana or how many people live in the city of Detroit. So what you do is, during the meantime, we work with samples, and that sample has to be representative of the population in order for it to be representative and for the data to be exact or to be accurate. All right, so any kind of a calculation made upon a sample is called a statistic. All right.
Recording in progress.
Oops. Somebody was making noise. Then they bounced off. I don't know who it was. I think it was. All right. Anyway. So in 11.1, they just mentions different types of sampling, different ways you can do it. It's really beyond the scope of this course to go out and do any sampling. I have used to do that in the past, but I haven't done it lately. But it gives you an idea of how the process works, and then you bring your data back and you combine it. But there's different methods to do it, and usually the thing that most people end up doing when they do sampling is convenience sampling, and that's oftentimes not a very good method to use. You have to have a plan, and the goal is to have a random sample. So stratified sampling is just where we go and we look at factors that already exist in the population, things such as race, sex, nationality, income, and then from each one of those groups we pull out a sample and then we put them all together. Cluster sampling is very similar in that we take data and we break it into groups that do not exist before, and then from those groups we pull out a handful from each one, put them together, and make our sample. As I said, convenient sampling is something that people often do. Back in the old days, I remember when there used to be malls a lot, there would often be somebody outside one of the stores grabbing you to come in and said, hey, let's get your opinion on this. And they would ask you questions about such and such. But the problem with that is you're only asking people that want to be in the survey. Same thing with kind of online polling. Oftentimes you'll see, take the poll. And again, the problem with those kind of polls online, they're very much what we would call for convenience sake, and only the people who want to will answer them. What we have to also deal with is people that may not be very social. They may not want to be asked questions, but yet they are part of the population. Oh, and another one that I might have mentioned is systematic sampling. And systematic sampling is where we might take every 10th person that comes in the door and answer a question. And that oftentimes happens in like a manufacturing facility where you would, if you want to take a sample of what's coming off the line, you might take every 10th one off. And again, there's problems with that. So each type of sampling method has its own issues, but the goal is to have a simple random sample that represents the population. And we have to assume that from here on out, that's what we've got to work with. Anytime we work with data, we assume that it's representative of the population. And then if we find out that it doesn't, then we're going to have certain cautions about it. All right, so what we've got here, and this is essentially what 11.2 is, this is where we first start doing things. And there's not really a whole lot of math to it. It's just a matter of paying attention to detail and keeping track of our data, because one of the things that we want to do with data after we collect it is organize it. Organize it in a way to where it will make sense to people if we want to pass it on. Now, a single piece of data is just one response. So let's say that I asked everybody their eye color and I put all that together into one file. Then each of the people in here, and it looks like there's about 20 folks, would have a response for their eye color. So if I pull one of those out, then that would be one piece of data. Now, one of the most important ways to organize data is through this vehicle called a frequency distribution. A frequency distribution is a listing of the values and how many times they occur for each of those, how many times that value occurs. Now, eye color is a good example, and this is one that we have. It's a model. We don't know what the model is, but just a bunch of raw data is not going to be very useful to us unless it's organized. I can show you that this is a textbook example of data, and even that is fairly modest compared to what most data actually looks like. And I'll kind of show you example of raw data. Well, when you have like just raw data, you have things that are a bunch of things in usually like a spreadsheet or some kind of fashion. And so here we got, and we don't even know what this is, but I'm just kind of showing you that there's a value. Maybe this is cost or whatever, but you'll notice that there's just a bunch of values in there. And that's an even simple one. Here's another example. We've got, this is probably looks like what this is. Looks like a country, I would probably say it's in Eastern Europe. And maybe these are states or counties or something like that, in the area in each one, and the per capita output. There's also the number of people employed. But just looking at all that data is not going to be very useful to us unless we organize it. And so organizing it is done with this thing called a frequency distribution, or it's one way to do it. All right. So let's look at how we might do this. This is what we call non-group data, or what Alex calls non-group data. I'm still not sure I understand why they call it non-group. I would just call it that it's naturally grouped, because right here, let's just say this is models for, I don't know, some kind of a phone. And all of these were collected at some point from maybe, let's see, there's 20 different values here. Okay, because we got 1, 2, 3, 4, 5, and we got 4 rows. 4 times 5 is 20. All right. And you notice that there's a bunch of B's in here, there's a bunch of C's in here, there's a bunch of E's in here, and there's a bunch of A's and also D's. And so what we need to do for the frequency distribution is go through here and count how many times each one of these appear. All right. So I'm going to go ahead and I'm going to use a little check mark. So every time I look at one of these, I'm going to go over here and I'm going to make a little mark, like a little hash mark. I don't know if you've ever done any of that tallying. And then E means that I'm going to go over here and I'm going to put a mark by the E. C means that I'm going to go over here and put one C. There's another A. Well, I'm sorry, there's our first A and another B. So then I can check these off. Because one of the hardest things about doing this is that you may not, you may get a little bit confused and wonder if you counted it or not. So that's why I'm checking them off and tallying them. So here's another A. So that's gone. We got another C. C, so that's going to be gone. And here we got a D, our first D. So that one's gone. We got a B. And that's gone. Here's a D. So that's going to be gone. So you see now we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we should have 10 tally marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when I'm finished tallying all of them, I'll be able to count them and know how many there are. Then next, it's an E. And then we got another E, a B, an E, another B. So that whole row is gone. And then we're going to go down to the last row. So there's a C, a B, another C, a D, and another A. So all of those are gone. So we can just check all those off. And we should have, let's see here. So I'm going to write these in. So this one is 3. This one is 6. Here's 4. Another 3. And then this is 1, 2, 3, 4. All right. And then let's see, we got 9 and 4 is 13 and then 7. So the total is 20. So the total should match the total number of values that we originally had because we don't want to leave anything out. But the important part are these things here, the 3, the 6, the 4, the 3, and the 4. This is what we call a frequency distribution. In particular, it's non-group because we didn't really have to create any classes because over here, because they were naturally grouped for us into only one of 5 different values. All right, any questions about that on how I got those? And this right here is just extraneous stuff. You know, we're not really looking at this part. We're only looking at that number. I have that because I took a screenshot of it from Alex and they have it where you can fill it in. So you can ignore that little box because we don't have anything to put in it. I might have been able to write in it, but like this, but I just wrote it outside because it's more room. So that's a non-grouped frequency distribution. We count up all the pieces of each model, write in that number, and we're done. And we can tally if we need to in order to keep track. All right. So let's get rid of all this and go on to the next one.
Can you make it extra interesting? Mr. Cruz, you sound boring, dry.
What?
I was saying, can you make it a little more interested? Like lighten up. Like
All
give us
right.
hope.
I'll see if
You
I can do
sound-
that.
you
I thought
sound
I was
dry.
being interesting. I thought I was
Gee,
being interesting.
No, you sound a little dry. Like
Well, it might be, but I'll try to see what I can do to interject something in here. All right. Counting, you know, numbers is not that interesting of a topic, so maybe that's part of it, but I'll see what I can do. All right. So now for grouped data, which is what Alex calls this, we have these things called classes, and it's a range of values. So let me put that here. A class is a range, or cubbyhole, you might call it, of values. So we're not just going to have one thing that is going to go in there. We're going to have a whole range of number values, and I'll show you in a second. And then we're still going to do the counting, but they could be anywhere within a specific range. All right. So the things we got to remember, though, for these classes is the classes need to be the same width. I'll explain width in a bit. The classes should not overlap, because if you got overlapping classes, something could feasibly go into one more than one class, and it should always only be in one class, a piece of data. And no gaps, because if we got gaps, then something can fall between the classes, slip through the cracks, as they say. All right. So here's some data here. We've got 12 pieces of data. All right, here we go in here. I'm going to circle it. So there's 12 values, and it could help to sort it, but I'm going to try to do it by using the Tallian. I think that'll make it work pretty well. Oops, and I probably should have started down here. So there's the values we're looking at. And so what I'm going to do is I'm going to kind of draw a little chart thingy here. All right, and as I said, this is called a class. And then this over here is going to be the frequency. In other words, how many times does it appear? All right. So let's do the Tallian thing like we did before. So 67, which one of these cubby holes does it fit into? Is 67 in here? Here, here, or here? The first one, right?
Yes.
All right, good, Daniel. So I want to make my little tally mark over here. And we'll come in and write the number. So 85.
Glass.
Be down here. So that one's gone. And then 74, which one does that go in? I think it goes right here in the second one, doesn't it? Right there, there's 74. 88 is going to be in the last one again. 75 in the second one, right? It was right there next to 74. 81 would be right here. '79 would also be right there, isn't it? Isn't 79 right there?
Yep.
So that's going to be gone. 80 is also right there, right? Am I just seeing things? There's going to be 80 in there. So 80 is gone. Now 69 is going to be up here. 82, back down to here. 81 is going to be in that same group. So we got 5 there now, and we're almost done. And then 73, the last one, goes in the second hole. All right. So that's all of them. So now I'm going to write in the frequency of each. So 2, 3. I'm sorry these don't match up. They don't have to. In Alex, there'll be a little box for you to put in. I'm trying to get them into a line as much as I can. And then this was 2. All right. So here's our frequencies right here. Okay. So that right there, and we don't include these over here, but this right here is the frequency distribution, this whole thing here. The tally marks are specifically for you to use to count with. All right, so what I'm going to do, I'm going to take a screenshot of this, and I want to use it in a little bit. Okay. All right. So any questions about how I did that?
I still don't understand. Can you do another one?
Well, I can, but let me just see what you got about this one. The reason why I hate to jump to another one is because usually the ones end up being bigger, and I'm trying to do it with a small one. So,
Oh, okay.
so what is it that, what happened to my data? Oh, that's right. This is the picture. There we go. So back up here. All right. So watch. 67 is in this range right here. You see this? That's 66 to 71. In other words, that would be in the class, it would be 66, 67, 68, 69, and 71 in that class right there, we call it. All right. So if that value 67 is any one of those, then that's why it goes in here. 67 went in that first slot. This next one has 72, 73, 74, 75, 76, 76, 77. Oh, this one's missing. I messed that up. It's got to be. I forgot 70. Let me fix that real quick. Nah. That's supposed to be 70, and then 71.
So what the 2 came in at again? 2 frequencies? What that came in at again?
There's 2 numbers. Look, let me show you. Let me finish this. Let me just erase the darn thing. All right. So up here, we've got 67, 85. Well, let me just go ahead and point at them. Maybe that'll be better. So 67. And the other one was, which one was it? 69. And then I'll write these back on here. 66, 67, 68, 69, 70, 71.
Oh, okay.
So both of those
see. So
values,
between
67 and 69, are the
fall
only
in
two
between
that
them,
are in
right?
this range here.
Okay, I got it.
Why is that disappearing? Oh, I bet you I clicked on that disappearing ink thing. Maybe that's what it is. I didn't know they had that. But anyway, that's the two that fit in this one. In this next one, see, it's anything that was any of these 5 values here. I'm sorry, 6 values. And there were 3 of them. There was 74, 75, 73 with a 3 for that one. On 78, 83, it was these 5. Not that one. So 85, well, not, I'm sorry, 85 wasn't in there. It's these 5 over here. 81, 79, 80, 82, and 81 are in the 5th one. I mean, I'm sorry, in the 3rd one where the 5 is at. And then there were 2 that were 84 to 85. So it was this one. And what was the other one at? 88 was the other one. All right, now, let me just point out, this is what we call a class width of 6, because each one of these has 6 values in it. See, this one has 78, 79, 80, 81, 82, 83. But rather than write them all out, we just recognize that they're in there because that's what it means when it says 66 to 71. And there's a class width of 6 also, you can see, because if you take any 2 that are right next to each other, these are called the lower class limits and the upper class limits. So let's say we take 84 and minus 78. Well, we get 6. So see, I'm looking at these 2 right here, that one and this one, and I'm subtracting 78 from 84. And that's how I get 6. You can do it up here too. You can do it on any 2 that are right next to each other. 60 or 72 minus 66 is also 6. You can also do it over here on this side. 71 from 78 is 6. 83 from 89 is 6. 87 from 83 is 6. So this is what we call a class width of 6 because there are 6 values in there. And I'm telling you this because, and kind of dwelling on it, because when people count, it's very easy to say that that's 5 because nobody counts the 66 because we're used to that kind of counting where, you know, we count 1, 2, 3, 4, 5, 6. We don't count the number that we start on, but that's part of the class width, all of those 6 values. So that's what it means when we say we have a class width of 6. All right, so let's see what else we can get into. One more type of, we're not really covering the misuse of statistics. Alex doesn't mess with that, so I'm not going to. But oftentimes graphs and charts can be misleading because of the way that they're presented. But anyway, let's just talk about charts, not really misuse of them. We just talk about charts and graphs. One of the most common ones is a pie graph, and it's useful because it represents 100%. And so you can break it into the different chunks, proportional chunks, and give everyone a percentage, and those percentages would add up to your total of 100%. But we're not really going to mess with that pie chart too much. We're going to the thing we're going to concentrate on primarily or first is called a histogram. Now, a histogram is a visual representation or a bar graph that comes from the information in a frequency distribution. All right, and let me show you. I'm going to go ahead over here. I got a board here somewhere. Let's go in this board. So this is from last time. All right. So I'm going to write on this whiteboard. All right. I have a blank whiteboard here. I'm going to go back to my annotate. And I'm going to erase this. And I'm going to import that file that I saved earlier. Let's see if I can do that on here. Thought I could do it. Yeah, uploads. So I'm going to upload that little file from my downloads. Would it be in my pictures? That's not that. Where did it go? Let me see where it's saved to. Oh, it's in screenshots. Okay, that's easy enough. I didn't know there was a screenshot folder. And here we go. All right, now, a histogram. What happened to it? All right, there we go. All right, so what we're going to do is we're going to create a graph, a bar graph, based upon this information. So I'm going to draw it out here. So hopefully this is getting more interesting. I'm trying to make it more interesting. All right. So this right here will be our frequency. And since the top value is 5, I'll make that 5. And I'll try to make them even all the way going down. And you don't have to do this by hand. I'm going to show you in Alex. There's a nice little tool. But I got to try and make a nice drawing at least once per class, even though I'm not any good at it. All right. So what I'm going to do here is I'm going to put a little mark here for each one of the classes. We got 4 of them. And this is going to be a bar. All right. So what I'm going to do here along the bottom is I'm going to write out the 66 to 71. And the bar here is going to represent that. 72 78 to 83, 84 to 89. All right, so that's those 4 classes. Like I said, it's kind of sloppy, but hopefully you get the picture. And then I'm going to go up to, for this one, I'm going to go up to 2. And then I'm going to create a little thing there. And then you can fill this in. Not perfect, but hopefully you get the idea. This one is going to go up to 3. All right. This one is going to go up to 5. And then this one down to 2. And now, like I said, is we want to imagine that everything's kind of colored in, so it looks like it would look in the ALEKS. So all this is blue, same color. Was that the only way they got the shade? I guess it is. That's better. But anyway, it's all marked in as 4 different bars. All solid color, same color, blue. All right, so that's a histogram. This is a histogram.
So what you just dragging the numbers over from the frequency to the graphic?
Exactly.
Okay.
Now let me show you over here, since you're on that train of thought. In ALEKS, I'll show you what it looks like. It's really a lot neater than the way I'm doing it. Like I said, you don't have to worry about drawing. I just try to draw just because I think at some point I'm actually going to make a good drawing, but it never happens. So in ALEKS, there is a little tool to do these. So I'm going to go down here. So where is that? So in ALEKS, see, it looks like this. So in other words, if I wanted to do this same one, and I'm going to do it real quickly, my first chart would be, my first bar would be 2. Second bar is going to be 3, 5, and then 2 again. And there's a little tool over here on the right to either add another one or take one away if there's too many. We only needed 4. So like I said, then you just type in here. Now the instruction, you don't have to write in the whole thing. You just write in the first part.
Okay, so you just write in the first set of numbers.
Yeah.
Yeah, that's how I got confused because I was putting in the whole.
Oh, you already tried it. Yeah,
Yeah,
I thought that's
already
the way
tried
it
it
worked.
and didn't know what I was doing, so I was like, "Well, I'm gonna wait."
Yeah. And I could have sworn in my head that it at some point you would put in the whole thing, but it does say label each class with its endpoint. But that's it. Yeah, you can only put one number. So the first one is called.
That what made me get it wrong then, because I was putting them numbers in and I was like,
Well, but
nope.
it don't let you put it in there, does it?
No, I was putting like the 0.2, like see how you put the 2 right there? I was putting like the
Oh,
numbers
okay,
in
yeah.
the 0.2
But that's the
exact.
frequency. The frequency is the vertical. The number of times is the vertical. This is what the values are.
Okay,
In
so
other
that's why I
words,
was getting confused there.
all right. So let's talk about one more thing in this section. And it's this thing called a stem and leaf. Stem and leaf. Stem and leaf is a different way to do these things, and it actually uses all the data and keeps the data, so you could kind of get your data back. Whereas with a frequency distribution, you just know what the values are in the range. You don't know exactly what they are. So here we've got some data, 20 different values, and it gives us data for an outpatient testing center and the number of cardiograms that were performed each day over these 20 days. So for day one was 25, 31, 20, and so forth. And this is right here is kind of strange, but they do it just to make sure things, you don't get, I guess you could say they're kind of babying us a bit, because generally you would write just 2 there if it was 2. But they want to, because the stem for this data is the tens column. In other words, it's 2, 3, 2, 3. That's the stem. It's the first number, the tens, and the ones is the leaf. Then they write the 0 there just to kind of show us that that's the stem. So now what I'm going to do is I'm going to draw a line here, and over here I'm going to put stem, and on this part will be the leaf. And so notice that there are 0 stem. We got a 14, so that's a 1. We got plenty of 2s, so 25s and 20s, so that would be 2. So I'm going to put those right here. So I'm going to put 0, 1, 2, 3, 4, and 5. Now, instead of writing the whole number, then what I'm going to do is I'm going to come over here and I'm going to write each one of these values here. And I'm going to kind of have to go through it in a similar way. In other words, kind of checking them off. So this right here would be 25. So that would go here with the 20 stem, because the stem is the tens, and I'm going to put a 5 there. So that represents 25. We'll go over to this one, 31. So I'm going to go down to the 3, and I'm going to put a 1 there. This one is another 20, but it's a 20-0. So that leaf is 0. So that's 20. That does not represent 50. That represents 25 and 20. That's the nature of the stem and leaf. And when this is all done, you'll notice that you can see the shape of the data. So this is 13, 14 is this next one. 43, that's going to be down here, our first 40. Here's that 02, so that goes here. That's the only one that's just a whole number. I mean, that's just a digit. 57, who's down here. 23 would go here in the 20 row. 36. 32, we got a lot of 30s. A 33. Another 32. A 44. Whoop. A 32 again. A 52. a 40, another 44, a 51, and then a 45. Now, as I had said is, all right, this represents the 0, 2, or the single 2. This represents 13 and 14. This represents 25, 20, and 23. See, we're only using the tenths one time. So 31, 32, 36, 32, 33, 32, 32, 43, 44, 44, 45, 57, 52, and 51. Okay, so that's a stem and leaf. So the stem and the leaf will vary depending on the problem. This is one from Alex. So, but it is entirely possible they might give you like a 3 digit number, and then they make the first 2 the stem and the last one the leaf. So pay attention to what they're asking you on that. All right, one last thing is measures of central tendency. Now, what measures of central tendency is, if we've got a data set, then we want to know something about what the middle of the data is like. Well, you already know about this if you've been in school for any length of time, because one of the most famous measures of central tendency, also called an average, is the mean. The mean is simply this. When we are asked to find the mean, right here, then what we do is we're going to take and we're going to add all these up. And there's 6 of them, so we're going to divide by 6. I'll come back and put in my fraction line there, so it looks like a regular old fraction. So we add them all up in the numerator, and so then this would be 60 over 6. Again, we're going to have a fraction line here. So then this is equal to 10. Anybody that's ever had average, test grades or anything would be using the mean. All right, but I'm sure that students know from experience what happens with the mean, that it's got a weakness. And its weakness is that it's sensitive to very extreme values. So if you have 5 tests in a class, 4 of them are in the B range, 80 range, and you have one really low one that's in the 30s, then what does that low value do to your average? It brings it down because it's sensitive to extreme values, because the mean uses every one of them. It treats them all equal. And so whether it's a low one or a high one, it doesn't care. So we're going to have 2 other measures of central tendency that will help us with that weakness. The next one is called the median. Now, with the median, we have to rank the data. In other words, we have to sort it low to high. All right. So let's see what we can do here. I got several to work. Probably won't be able to work all of them, but I'm going to work key ones. So on this one here, what happens with the median is we rank the data low to high, and we find the middle value. If there's an odd number of pieces of data, then there will be one value in the middle. if there's an even number, then there's not going to be one in the middle. There will be two. So therefore, we add those up and divide by 2. In other words, we go back to our mean. So let me show you. I'll make some room here. So for this one, we want to find the mean, median, and the mode. Let's do the mean first. I mean, the median first. Well, what we got to do is sort it. So this is that number 1 up there. So we're going to sort data low to high. So that's going to be 2, 3, 7, 10, 8, 10, 10, 31. So that's this data right here sorted. All right. And there's 1, 2, 3, 4, 5, 6, 7. Now, because there's 7 values, there's going to be one value that's right smack dab in the middle. See, you got 3 on either side. So the median is equal to 8 in this case. It's the one in the middle. Now, the mode is the piece of data that occurs the most frequently in the data set. All right. So look at that same data set that we just calculated the median on. Can you tell if anything repeats more than others? I'll go back up here. 10 is the only number that repeats. So the mode is equal to 10 because 10 appears more than any of the other data values. 3 is unique, 7 is unique, 8 is unique, 31 is unique, 2 is unique. The only one that repeats is 10. So by default, that's our mode. All right. So let's look at number 2 for the median. This one's already sorted. Okay. This data is already sorted. I'm just going to copy it and paste it down there. So how many pieces are there of data are there? Let's see. There's 1, 2, 3, 4, 5, 6, 7, 8. They're already sorted, but here's the obvious problem with this one is there's no one middle value. There's no one middle value because there's 8 pieces of data. So what that means is there's 2 values in the middle. All right. 2 values. So what do? When there's an even number and therefore 2 middle values? We're going to add up 21 plus 21 and divide by 2. Divide by 2, and that's going to create a median value for us. Now, in this case, it's because we're adding the same number twice and dividing by 2, it ends up being the same number. So the median here is 21. Okay. The median is 21. All right, so let's go back up to these and look at the modes. on the rest of these. So on this one, we have another one where 4 appears, they're all sorted, so this should be easy to see. 4 appears 4 times, 1 only appears twice, 2 appears 3 times, 5 appears twice, but 4 is by far the winner. I like to think of it as a race. There's more 4s than anything else. So 4 is the mode. Now, if the data is all unique, like this right here, 2, 3, 5, 7, 8, 9, 10, and 12, there is no mode because there is no race. None of them get past the starting gate. All of them only exist once. And then the last possibility is you can have multiple modes. So on this one, we've got 2 2s, we got 2 1s, and we got 2 3s. All of the other ones are unique, but there's a tie between 1, 2, and 3. So therefore, 1, 2, and 3 are the modes. All right. I got one more thing to do. It's going to be a rush, but this number 6. It's using the frequency distribution that we just created. Well, let's create the find the mean for that. All right. So here's what we're going to do. We're going to create one more line here. I think we're probably going to need 2. And what we have to have is the midpoint. The midpoint is simply, we're going to take, let me put that right here. So the midpoint is just halfway between 66 and 71, which is real easy to find because we're just going to take 66 plus 71, and then we're going to divide by 2. And so our midpoint is 68.5. And now I'm just going to keep adding 6 because the class width was 6. And that'll give me the rest of them. So 74.5 would be the next midpoint. And you can add those up as well and divide by 2. Plus 6. So this is 80.5 for that midpoint. You could add them up and divide by 2, you get the same thing. And let's see, this is 86.5. So there's our midpoints. Now, one more thing. Midpoint times frequency. So I'm going to multiply 2 times 68.5. See, the original data is gone. Oops. So we got to essentially approximate what the data was like. So what we're doing is we're just assuming that we're going to use the midpoint in place of the individual data pieces and just multiply and show that there was 2 of them. So 74.5 times 3 is going to be 223.5. And then the next one is going to be 5 times 80.5. So that's 402.5. And then the last one is 86.5 times 2 again. So this is 173. All right, so I'm going to add all these up. 173 plus 402.5 plus 223.5. And what this does is it gives us a sum of all of our data, essentially, data points, just like we were doing when we're adding them all up and dividing by. So 936. And then we had 12 pieces of data over here for the frequency. There was 12 pieces of data. So our mean is equal to 936 divided by 12, which is 78. So our mean for this grouped data is 78. And you can kind of see that that makes sense because 78 is right here. So it's almost smack dab in the middle. All right, so that's it for tonight. We'll jump into 11.4 next time. Like I said, is this right here was kind of the most complicated part, which is usually what I end up ending on. So then next time we'll talk about the measures of variation. So don't forget about the take-home test being due on Thursday. This is meant to be something easy and non-stressful, so take advantage of it, all right? And
Thank
then you're
you.
also preparing for the final exam in the 020 in 1 week on the syllabus in the 020 syllabus calendar, addendum calendar. All right, so see you Thursday for more new stuff in the morning. In the first class, we'll still be reviewing for that final in the 020. Make sure and work on that review because that's the key to doing well in that.
Mr.
Yes,
Sorry,
Naomi?
I didn't show up to your first class. Work got me and I was driving. Sorry.
All right. Well, just realize that we
Yeah.
had an assignment in there to prepare for the final exam in the 020. It's not due, wasn't due today, so it'll be due before class in 1
Okay.
week. Work on
Yeah.
that.
Okay.
That should be a pretty easy exam to ace. All right.
Okay. All righty. Thank you.
Okay.
All right. Have a great one. Bye.
Okay. Bye-bye. All right.
Hello?
And if you need anything, just stop by. Yes. Who is it?
Hey, it's Lopez, David.
Oh, David. Hey.
Yes. The reason I keep bugging about the midterm with